Have you ever thought of spacetime not as a fabric, but as pure information? This idea isn't science fiction. It's a cutting-edge perspective in contemporary physics. If reality is fundamentally data, that means spacetime itself could be an emergent phenomenon, something that arises from more basic informational building blocks, kind of like pixels on a screen forming an image. But what does that even mean? To understand this, let's dive into quantum mechanics and general relativity. Quantum mechanics describes the universe in terms of probabilities and discrete units of energy, while general relativity describes spacetime as a smooth, continuous sheet that bends and warps due to mass and energy. And here's the problem. These two frameworks don't really play nicely together. Combining them breaks down into mathematical chaos, singularities, infinities. It's like trying to mix oil and water. But what if they're just two sides of the same coin? A coin made of information. Now, here's where information theory enters. In 1948, Claude Shannon formalized the concept of information, which measures uncertainty or ignorance before data resolves it. Remarkably, physicists are finding that the very essence of reality, everything from black holes to particle interactions, can be described not as matter and energy, but as a flow and computation of information. Ever heard of Wheeler's "it from bit"? It suggests that all things emerge from binary yes-no decisions, the basic ones and zeros of computation. Imagine the laws of physics themselves coded in a cosmic programming language. One compelling application of this theory shows up with black holes. Here's the deal. Black holes store information about everything that falls into them, not as matter, but encoded on their surface area, their event horizon. This idea, called the holographic principle, implies that our three-dimensional universe may be a projection of two-dimensional information encoded on a cosmic boundary. Mind-blowing, right? The concept of spacetime as emergent isn't flawless. Critics ask, if spacetime emerges from information, then from what does information emerge? Just trading one mystery for another? Maybe. But theories like this suggest we're inching closer to a unified understanding of quantum mechanics and gravity. If your brain isn't overloaded yet, and you're hungry for more short or in-depth dives into advanced physics, tech, and philosophy, subscribe to Hyperfocus. I'll see you there.